Okay, here is problem 3 on the midterm. Given two vectors, find an orthogonal set of vectors whose spin is equal to the spin of u and v. Let's start with that. Now we're going to be using the Gram-Schmidt procedure. Unfortunately, we're only trying to find two orthogonal vectors. So we don't need all of this. We actually only need the first term here. Now here I have u and v, but this talks about starting with v1, v2, v3. So if I'm going to apply this formula, I really should call this one v1. This would be my v1, and this would be my v2, if I'm going to apply this formula. All right. So here I have, well, let's look at this. According to this, the resulting orthogonal vectors would be the u's, and so I'm going to have two u's because I started with two v's. So let's take a look and see what u1 is going to be. Now, according to this formula, I start with v1, and then I take these negative terms. How many negative terms do I take? Well, up to ui minus 1. Now, there is no u0, so in fact there are no negative terms at all. So u1 equals v1 is my first vector. So that's 1, 2, 2. So let's go ahead and find the second one, which would be u2. Now u2 is what? In this case, you're using this formula with I equals 2, so that gives me v2. And we're subtracting u1 inner product with vi, and the vi is v2. Now notice that u1 is equal to v1. So instead of saying u1, I'm just going to put a v1 here. There's v1, v2 on the top. Again, here I have u1, u1, but u1 is the same as v1. So I'll put v1, v1 on the bottom. And then I want to multiply this by v1. So that's the formula for u2. All right, so let's go ahead and do this. v2 is 2, 2, 1 from the top. And I'm subtracting inner product of v1 with v2. Now, since these are real vectors, I don't need to worry about the complex conjugate because they're real vectors. So let's do the inner product. The inner product, well, let me do the inner product one up here. v1, v2 is equal to, let's see, 1 times 2, or 2, plus 2 times 2, which is 4. That's the second component. And plus 2 times 2 is 2, so that's 8. Okay, so that's v1 inner product with v2. Let's look at v1 inner product with v1. All right, that's going to be 1 times 1, or 1, plus 2 times 2 is 4, plus 4 equals 9. Okay, so here I have 8/9 times v1, which is 1, 2, 2. All right, so if I write this, 2 is 18/9 minus 8/9 gives me 10/9. 2 again is 18/9 minus, and this is 16/9. 18 minus 16/9 is 2/9. Okay. Here's 1 minus 16/9. 1 is 9/9, so that's minus 7/9. Right. So here is my other vector. So my two vectors are this one and this one. I can call this my u1, and then this my u2. Now, it's good to check and make sure they are orthogonal. So here's a check. And take the u1 inner product with u2. That's a u, sorry. So that's going to be equal to 1 times 10/9, which is 10/9. And then here I have 2 times 2/9, which is 4/9. And then I have minus 2 times 7/9, which is minus 14/9. It's equal to 0. All right, now notice something also. I could have chosen u2 equal to 10, 2 minus 7, because I didn't say anything about orthonormal, just orthogonal. And if you multiply a vector by a number, then if it's orthogonal to another vector, the multiple will also be orthogonal. So yes, so I could also have done that. All right. So let's go on to part B. Part B is asking for orthonormal. And what that means is you have to divide U1 and U2 divide U1 and U2 by their norms. You need to divide by their norms. Okay. So that gives me, let's call it, I don't know, we'll call W1. W1 will be the orthonormal version of U1. So that's going to be what 122 divided by, now the norm is the square root of U1, of inner product of U1 with itself. Okay. Now I already found the inner product of U1 with U1, which is the same as V1 with V1, and that's 9. So that's giving me equals 122 times 1/3. I kind of wrote this informally. What this means is times 1/3. Okay. So that's going to give me 1/3, 2/3, 2/3. That's the first one. So that's going to be my first orthonormal vector. And then W2 is equal to this other one. Let me just go with this 10 to minus 7. It doesn't matter which one I use, but I think it's easier to compute the norm of this divided by the square root of U2, where here my U2 is this one with a 10 to minus 7, so it's equal to 10 to minus 7 over the square root. Let's see, I have 100. It's 10 times 10 is 100. 2 times 2 is 4. 7 times 7 is 49. So that's 153. Is that right? 153 times 1 over square root of 153. And I believe that's divisible by 9. So I think that turns out to be 1 over 3 square roots of 17, I believe. You can check that. I think that's correct. Times 10 to minus 7. All right, so my two orthonormal vectors are this one. This is my W1. And then this is my W2. Okay, that's it.